Welcome to this video on solving one-step inequalities. This process should look very similar to the process of solving one-step equations. So let's just jump right into some examples. X plus 7 is greater than -3. Since the goal, like with solving equations, is to isolate x on one side, we need to get rid of the plus 7 on the left side. We do this by subtracting 7 from both sides, just like with a one-step equation. So this will give us x is greater than -10. And this is our answer for our inequality. Sometimes when you have one-step inequalities, you'll be asked to graph your solution. So if you were to graph this solution, it would look something like this. So we'll have 0, and then we'll go all the way up to 10 on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm just going to label 10 so we don't forget. And then we'll go to -10 on this side. So we'll have -10 over here. And then when we graph, we have a greater than sign. It's not greater than or equal to, so that means that -10 is not part of our solution set. So to show this, we draw an open circle over -10. That means that -10 is not included. And then x is greater than -10. So our arrow will be to the right, like this. Now let's try another one. X minus 2 is less than or equal to 3. So to solve for x, we need to get rid of this -2. So to do that, we'll add 2 to both sides. This gives us x is less than or equal to 5. Now let's draw a graph of our solution. So again, we'll draw our number line. We'll put 0 in the middle. You don't have to have 0 in the middle, but typically that is what you'll see. So that's why I'm drawing it that way. And then I'm going to go over 10 to both sides, just like we did last time. So we have 10 over here, and then on the left side, we have -10 right here. So because we have a less than or equal to sign this time, we're going to go to 5, and we're going to include 5 in our answer. So the way that we show that is with a closed dot instead of an open dot. So let's find 5. We have 1, 2, 3, 4, 5. And we're going to shade in our dot to show that it's less than or equal to, that 5 is included. And since it's less than, we're going to draw our arrow to the left, just like this. Now let's try an example where we have to use division. -4x is greater than or equal to 16. To isolate x, we have to divide both sides by -4. However, before we go forward, I need to tell you of one special rule. When we divide or multiply by a negative number with inequalities, we have to flip our inequality sign. If you don't, your answer will be wrong. So here, our answer will be x is less than or equal to -4. It's very important that you flip your inequality sign when multiplying or dividing by a negative number. Now let's graph our answer. So for this one, I'm just going to go to 5 on either side. So we'll have 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So -5 over here on the left. So since we have a less than or equal to sign, we're going to draw our dot over -4 and shade it in because it's equal to. And then it's less than or equal to, so we're going to draw our arrow to the left. Let's work through one more example together. X divided by 6 is less than 1. To isolate x, we need to multiply both sides by 6. So when we do that, we'll get x is less than 6. Because we multiplied by a positive number, we don't have to flip our inequality sign. Then we can graph our solution. So again, I'll go to 10 on either side. So we have 10 over here on the right side, and -10 over here on the left side. We're going to draw an open circle above 6. So we're going to start by finding 6. 1, 2, 3, 4, 5, 6 right here. And draw an open circle because it's less than and not less than or equal to. So this shows that 6 is not included in our solution set. and then it's less than. So we're going to draw our arrow to the left. And there we have it. I hope that this video on solving one-step inequalities was helpful. Thanks for watching and happy studying.